August 1st, 2012, 9:30 a.m. Knight Capital Group's trading algorithm goes live. By 1:10 a.m., just 45 minutes later, the company has lost $440 million. Not in a market crash, not due to some external catastrophe, but because of a single, reused software flag called SMARS that behaved differently on one server than the other 7. The system bought high and sold low at a frantic, automated pace while human operators watched in horror, powerless to stop the digital carnage. This is what happens when architects lose touch with the systems they're supposed to control. Welcome to Mindcast. I'm Will, and today we're diving deep into one of the most important research papers you've probably never heard of, the Neo-Artisan, Reintegrating Execution and Design in the Age of Agentic Systems. This isn't just another tech paper, it's a manifesto for survival in the AI age. Why we're entering what the authors call the fourth computing paradigm, where AI does all the coding grunt work, but creates terrifying new risks of what they call accountability collapse. We'll travel back to Victorian England to meet Thomas Cubitt, the master builder who understood both the grand vision and the weight of the stone. And we'll discover why the future belongs not to pure theorists, but to what they call neo-artisans, leaders who can walk the walk in the age of artificial intelligence. Trust me, by the end of this episode, you'll never look at AI the same way again. Let me start by blowing your mind with some numbers. A team of 16 AI agents recently built a complete C compiler that's 100,000 lines of Rust code for about $20,000 in API credits. A human team doing the same work, $150,000. That's a 90% reduction in cost. Code, quite literally, has become a commodity. It's like the difference between hand-carved stones and mass-produced bricks. But here's the catch, and this is where our first key insight begins. This collapse in the cost of code creation is creating what the authors call a crisis of competence. Think about this for a second. When the cost of creating code plummets to nearly zero, what happens to the value of knowing how to code? Most people think, great, we don't need to understand the technical details anymore. We can just tell the AI what we want. This is exactly the same thinking that led to the Knight Capital disaster I opened with. Someone assumed the software flag would behave uniformly across all servers. They were wrong, dead wrong, to the tune of nearly $500 million. The authors argue we're entering the fourth computing paradigm, where the fundamental unit shifts from static applications to fluid capabilities managed by what they call an Agentic Operating System. In plain English, we're moving from a world where humans write software step by step to a world where we describe what we want and AI agents figure out how to build it. Sounds amazing, right? Here's the problem. When you don't understand how the sausage is made, you can't tell when it's gone bad. This brings us to one of the paper's most brilliant insights, something called the ironies of automation. This concept actually dates back to 1983 from researcher Lisanne Bainbridge. The irony is this: automating the easy parts of a task makes the human operator's job harder, not easier. Here's why. As humans stop performing the manual work, what the paper calls walking the walk, their skills deteriorate. So when the automation inevitably fails in some unexpected way, they're expected to take over, but they no longer have the knowledge or intuition to diagnose what went wrong. It's like being asked to land a plane when you've only ever been a passenger. The AI agents can write syntactically perfect code that completely fails to meet real-world constraints. They can hallucinate dependencies, ignore hardware limitations, or create security vulnerabilities you'd never catch without deep technical knowledge. This is what the authors call accountability collapse, where the chain of responsibility dissolves into what they beautifully describe as a fog of hallucinated code and unverified intent. So how do we solve this? That brings us to our second key insight, and it involves a fascinating journey back to Victorian England. Meet Thomas Cubitt, often called the greatest Victorian builder. But here's what's remarkable. He didn't start in some fancy architectural firm drawing pretty buildings. He started as a carpenter's apprentice. For 7 years, Cubitt got what the paper calls a tactile education, learning the grain of timber, the weight of stone, the way different materials behaved under stress. This wasn't just manual labor, it was material science at the most fundamental level. While his contemporaries, the gentleman architects, understood materials in abstract aesthetic terms, viewing a stone column as a reference to antiquity, Cubitt understood it as a load-bearing entity that could crack, shift, or fail. When Cubitt was commissioned to develop the grand residential estates of Belgravia, one of London's most prestigious districts today, he faced what they called the Five Fields, basically a notorious marshy wasteland. A purely theoretical architect might have focused on the layout of squares and the ornamentation of facades, leaving the dirty work to subcontractors. But Cubitt, he applied his technical knowledge of groundworks to the problem. He used soil excavated from the construction of St. Catherine's docks to raise the level of the site and engineered complex drainage systems to stabilize the marsh. This wasn't aesthetic, it was existential. The stability of those grand terraces depended entirely on this invisible subterranean engineering. And guess what? Nearly 150 years later, those buildings are still standing in excellent condition. Why? Because Cubitt understood what the paper calls the limits of natural materials. He walked the walk. He knew how Earth moved and how foundations settled, so he could envision a solution that transformed a wasteland into one of London's most valuable districts. Cubitt's greatest innovation was actually administrative. He invented the modern general contracting system. Instead of clients managing separate contracts for each trade, bricklayer, mason, carpenter, leading to cascading delays, Cubitt integrated them all. He employed artisans directly and even manufactured his own materials, firing bricks from clay on his sites to guarantee what he called intrinsic goodness of construction. Now, you might be thinking, okay, Will, that's a great history lesson, but what does this have to do with AI? Everything. Because just like Cubitt needed to understand the properties of stone and timber, today's leaders need to understand the properties of AI agents. This brings us to our third key insight, the new material science. AI agents aren't just smart helpers, they're a new kind of building material with their own physics, and if you don't understand these properties, you're building on quicksand. So, what are the material properties of AI agents? First, they're stateless. They forget who they are every few seconds, existing only in the fleeting movement of their context window. Second, they're time-blind, with no perception of project schedules or continuity. Third, they're prone to hallucination, basically making stuff up when they don't know the answer. And fourth, like stone under pressure, they degrade when too much information is forced into their context window, losing focus and forgetting in the middle. The paper describes a perfect example of this with something called the 16-bit failure. The AI agents were tasked with building a C compiler that could handle the Linux boot process. There's this archaic part of computer startup that requires code to fit within extremely tight memory limits, often 32 kilobytes or less. It's like trying to pack for a month-long trip in a carry-on bag. The AI agents produced code that was syntactically perfect. All the grammar was correct, all the references were valid, but the resulting program ballooned to over 60 kilobytes. It was like building a beautiful door that was twice as wide as the door frame. As the paper puts it, the agents could not reason their way around this physical hardware constraint. So what happened? The human architect, Nicholas Carlini, had to intervene. But here's the crucial part.
he didn't fix it by writing the code himself. Instead, he implemented what the paper calls a cheat. He configured the build system to route that specific tricky part to an existing reliable tool called the GNU assembler, while letting the AI agents handle everything else. This is the defining moment of what the authors call the Neo-Artisan. Carlini understood the system deeply enough to know that 16-bit code generation was a weakness of the AI model, and he knew that a reliable alternative tool already existed. He architected a systemic bypass.
An ivory tower architect, someone who didn't understand why the agents were failing, might have just prompted the agents to try again or fix the bug, leading to an infinite loop of failure. But Carlini didn't need to lay the bricks himself. He absolutely needed to understand why the bricks were cracking. This illustrates a fundamental principle. You cannot architect the harness if you do not understand the horse. The intelligence of the agents was insufficient without the systems architecture provided by the human.
To manage these AI agents effectively, Carlini had to design what the paper calls a Ralph loop, a digital equivalent of Qubit's general contracting system. This harness managed 4 critical friction points that the agents couldn't handle themselves: state synchronization to prevent fragmentation of reality, concurrency controls to stop agents from overriding each other's work, execution and verification gates, and creating an illusion of persistence for time-blind agents. Think about this. The human didn't write the 100,000 lines of code, but he had to understand file systems, locking protocols, race conditions, and Git histories to make it all work.
Now, you might be thinking, this sounds like a lot of work. Why not just have the AI figure it all out? And this is where we get to one of the paper's most important warnings about accountability collapse. This happens when human leaders assume AI agents are intelligent enough to handle everything and hand over control without verification systems. The authors reference Nicholas Carr's concept of the glass cage, how automation leads to a de-skilling that creates a gulf of envisioning. If you don't understand the capability and constraints of your tools, you can't envision creative solutions. You're trapped in the parameters of your current experience.
So what's the solution? How do we become neo-artisans in the AI age? The paper proposes 3 core principles, and these apply whether you're in software development, finance, healthcare, marketing, or any field where AI is taking over routine tasks. Principle 1: orchestration over syntax. You don't need to lay every brick yourself, but you absolutely must know how to design what the paper calls the scaffold, the frameworks that keep AI agents coordinated and productive. This means understanding the workflows, the verification points, the failure modes, and the recovery mechanisms. Principle 2: verification over trust. You must treat AI output with the same skepticism that a master mason treats a cracked stone. The paper introduces this concept of verification sensitivity, the intuitive sense of when an AI agent is hallucinating or when a system is about to break. This isn't paranoia, it's professional competence. You need what they call oracle strategies, external sources of truth to verify AI output. You cannot ask an AI to verify itself. You need independent validation systems. Principle 3: constraint management. You must understand the physics of your system, context windows, hardware limits, what the paper calls the zoning laws of technology. When AI agents hit these walls, you need to know how to architect around them, just like Carlini did with the 16-bit problem. This requires what the paper calls material sensitivity, knowing the grain of the AI, understanding where it's strong and where it's brittle, where it excels and where it fails. The paper makes a fascinating observation about education and career development. Universities are starting to declare that coding is dead, that the ability to write a for loop is now as commoditized as the ability to cut a straight line in wood. Instead, curricula are shifting toward product deconstruction, agent orchestration, and what the authors call verification sensitivity. But here's what concerns me. As senior engineers retire and bricklaying is automated, organizations risk losing the mentors who can teach the next generation the secrets of the trade. This is what they call the loss of tacit knowledge, the unwritten, experiential wisdom that can't be easily codified or trained into an AI.
This isn't just an academic concern, it's a corporate survival issue. The paper cites real disasters like Boeing's 737 MAX, where management disconnected from engineering reality made decisions about automated systems they didn't truly understand. Or Lidl's $500 million SAP implementation failure, where business leadership's ivory tower plan didn't account for the granular reality of their inventory system. The pattern is clear. Organizations that rely on leaders without deep understanding of their underlying technologies face catastrophic risks. The democratization of expertise promised by AI creates a paradox. While it allows high-level orchestration without low-level manual labor, it simultaneously increases the requirement for high-level technical intuition.
The authors conclude with something that really resonates with me. The systems architect must fundamentally be a builder at heart, one who has walked the walk of the digital substrate, ensuring that when the agents lay the bricks, the cathedral remains standing. Think about Thomas Cubitt transforming a marsh into Belgravia because he understood both grand vision and drainage engineering. Think about Nicholas Carlini enabling AI agents to build a working compiler because he knew when to trust them and when to route around their limitations. The transition to what they call the agentic systems era isn't a departure from the past, it's a spiraling return to it. We're leaving the era of the pure specialist and returning to the era of what they call the generalist master builder, the Neo-Artisan. Walking the walk in 2026 doesn't mean memorizing programming syntax or knowing every technical detail. It means understanding the material properties of AI agents, their statelessness, their time blindness, their tendency to hallucinate under pressure. It means designing verification systems that can catch failures before they cascade. It means knowing when to trust the automation and when to architect around its limitations. The future doesn't belong to the person who can write the most lines of code. That's the machine's job now. It doesn't belong to the pure theorist who designs from an ivory tower. It belongs to the Neo-Artisan, someone who can envision the cathedral and understand why the foundation might crack. So here's my challenge to you. Whatever field you're in, don't just learn to prompt AI better. Learn to verify AI better. Understand the constraints and failure modes of the systems you're orchestrating. Develop what the authors call material sensitivity to the AI tools in your domain. Because the cost of abstraction without understanding isn't just inefficiency, it's Knight Capital losing $440 million in 45 minutes. It's Boeing planes falling from the sky. It's billion-dollar system implementations that fail because leaders couldn't bridge the gap between intention and execution. The friction points, the ivory tower failures, the gulf of envisioning, the accountability collapse are all symptoms of a single disease, the decoupling of authority from understanding. The cure is the reintegration of the two. The future belongs to the Neo-Artisans. Will you be one of them? That's our deep dive for today into the Neo-Artisan, reintegrating execution and design in the age of agentic systems. If this episode resonated with you, please share it with someone who needs to hear it, especially if they're in a leadership position navigating the AI transformation. I'd love to hear your thoughts on this. Are you seeing the patterns described in this paper playing out in your own organization? Have you experienced moments where understanding the underlying technology made the difference between success and failure? Drop me a line. I read every message. Remember, in the age of AI, the most valuable skill isn't knowing how to build. It's knowing how to build responsibly, with deep understanding of both the possibilities and the pitfalls. I'm Will, and this has been Mindcast. Until next time, keep questioning, keep learning, and above all, keep walking the walk.